Hello students, in this video we are going to discuss mechanism of nucleophilic substitution reaction. Nucleophilic substitution reaction of alkyl halide has been found to proceed through two types of mechanism, that is SN1 mechanism and SN2 mechanism. Before going into the details of this mechanism, let us find what the S means here, what N means, what 2 and 1 means. Here S represent substitution, N represent nucleophilic, and 2 and 1 represent the reaction kinetics. That means if the rate of the reaction is unimolecular, then it is represented as 1, and if the rate of the reaction is bimolecular, then it is represented by 2. That means here the number 1 and 2 represent the reaction kinetic. Let us take one alkyl halide. Here it is an structure which is given for a methyl chloride, or we can say methyl halide. X is represented here. Because of the presence of CX bond, the nucleus substitution reaction, that is nucleophilic substitution reaction, takes place. But this is actually sp3 hybridized carbon, so it have a tetrahedral geometry. So if we find its tetrahedral geometry, it will be in this way. That means it have one CX bond and the other all bond. These are actually tetrahedrally arranged. Let us check this reaction. Here the nucleophile approaches the haloalkane and it attacks the partially positive carbon atom, that is this carbon atom. As we know that the negative charge attracted toward the positive charge, so it get attached to the partially positively charged carbon atom, and with the leaving of the X, it gives rise to the product, that is nucleophile get attached and X, that is the leaving group halogen, is removed. So how this reaction takes place? Let us discuss the mechanism. Here the nucleophile which is negatively charged is attacking on the partially positive charged carbon atom which is present in the CX bond, and it attacked from 180 degree angle from the halogen atom. You can check the angle will be 180 degree angle from the halogen atom. So it make a temporary bond with the carbon atom. So it makes a structure which is called as unstable structure, and it was called as transition state. We can say unstable intermediate is formed. Then finally the X get removed. This bond will break, that is CX bond break, because it is an unstable, and the X will be removed, that is leaving group is removed and the product is formed. So how this reaction is taking place? The reaction is taking place by the formation of an intermediate here, that is an unstable intermediate formation takes place, and then only the product is formed. So this is represented as the step 1, and this one will be the step 2. So this reaction is taking place in 2 steps. As we have learned in the kinetics, chemical kinetic, that is when the reaction takes place in more than one step, then the step which have slowest step is the rate determining step. So in this step, step 1 is the slowest step, therefore we call this step as rate determining step. So when we find out the rate will be is equal to K concentration of a alkyl halide and the concentration of nucleophile, because in the first step the two reactants are nucleophile and haloalkane. So the rate will be equal to K, that is a constant, into concentration of both reactants. So in this step, that is in the first step, there are two reactants Therefore, we can say that the reaction is bimolecular. So why it is called as substitution nucleophilic bimolecular? Because in the rate determining step, the concentration of both reactant take place an important role for deciding the rate of the reaction. Therefore, we can call it as a bimolecular. Once again, because the rate depends upon the concentration of both the reactant, therefore, this mechanism is called as substitution nucleophilic bimolecular, that is SN2. So S represent for substitution, N represent for nucleophilic, and 2 represent bimolecular. So that means in the rate determining step, both reactants, the rate depends upon both the reactant, therefore it is called as SN2. Reactivity of alkyl halides towards SN2 reaction. In this, when we checked here, there is alkyl halides are given. In the first case, that is methyl halide. Second one is 1 degree. Next 2 degree, 3 degree. So here methyl halide 1 degree, 2 degree, 3 degree, that is primary, secondary, tertiary halides are shown here. When you check the structure here, the nucleophile, because it is attacking from 180 degree angle to the halogen. So in the first case you can find that because H are there in this, 3 H are there, which is smaller in size. Therefore, it is easy for a nucleophile to attack on this carbon, that is partially positive carbon. But if there is one alkyl group on this partially positive carbon, so which is little bit bulkier than the other hydrogen, so it will be little bit difficult for the nucleophile to attack the partially positive carbon. When we check the third case, in this case there are 2 alkyl groups. You can check there are 2 alkyl groups and only one hydrogen is there. So the nucleophile again find difficulty to approach this carbon because of hinderness. And the third case also there are 3 alkyl groups, 1, 2, 3. There are 3 alkyl groups. So again the nucleophile find difficulty to approach, or we can say difficult to attack the partially positive carbon atom. So it is found that when the size of the group, or we can say when the size of the group increases, we can say the hindrance increases. That hindrance is called as steric hindrance. That means it is not easy for the nucleophile to attack on the partially positive carbon because of the bulkier size group, or we can say the bulkier size alkyl group which is surrounding to that carbon. So greater the size of the alkyl group, difficulty will be the nucleophile to attack the partially positive carbon. So we can say that the reactivity decreases. So when we compare, that is methyl halide 1 degree, 2 degree, 3 degree, when we compare, it will be more easily the reaction takes place in the case of first, that is methyl halide, then in the case of second, third. So this is the order of reactivity of alkyl halide towards the nucleophilic substitution when it undergoes through SN2 reaction. Let us take an example. In this example, it is a 3 degree alkyl halide because there are 3 alkyl groups. One here, second here, third. There are 3 alkyl groups on the partially positive carbon atom. So it is a 3 degree alkyl halide. Here, this partially positive charged carbon is surrounded by 3 bulkier group. So as we have discussed in SN2, it will be quite difficult for a nucleophile to attack on this carbon. So at the time it undergoes another sort of mechanism that we are going to discuss. So let us, the reactant, the nucleophile and the alkyl halide, it gives rise to the product with the removal of leaving group. Let us check how this reaction takes place. In this, first the reactant, that is alkyl halide, there is a cleavage of CX bond. First the cleavage of CX bond takes place. So the X negative is removed. So it results in the formation of carbocation. You can check here, one X negative is removed, one positive charge will be formed on the carbon atom. It is called as carbocation. Then only the nucleophile will attack, and easily the nucleophile can attack on this positive charged carbon. So we get this product. So this reaction is taking place in two steps. That is, in the first step, there is a cleavage of CX bond results in the formation of carbocation, and in the second step, then the nucleophile attack to form the product. So here also two steps are there. Step 1, that is, this is the step 1 and this is the step 2. Here step 1 is the rate determining step. So in the rate determining step, there is only one reactant. So we can say that a rate is equal to K, that reactant. So here only one reactant is there in the rate determining step. Therefore this mechanism is called as substitution nucleophilic unimolecular. That is SN1. It is called as SN1. Reactivity of alkyl halide towards SN1 reaction. As we have discussed in the case of SN2 mechanism, when the hindrance, that is steric hindrance, increases, we can say that in that case the reactivity was decreases. But here the reactivity increases with the increase in the steric hindrance. Why? Because as we have learned in the previous class that carbocation, stability of carbocation, that is 3 degree is more stable than 2 than 1. So in this also there is a formation of an intermediate, that is a carbocation. So in the case of a 3 degree carbocation which is more stable than the 2 degree, than the 1 degree. So we can say that the stability of carbocation increases, therefore the reactivity also increases. So the order of reactivity for the substitution, nucleophilic substitution reaction, that is unimolecular nucleophilic substitution reaction, will be this. So when we compare the reactivity of alkyl halide towards nucleophilic substitution, we can find that it takes place in two ways, by SN1 or SN2 mechanism. In SN1 mechanism, the reactivity increases with the increase in the bulkier size group. In SN1, it increases with the increase in the bulkier size group. So in SN1 reaction, 3 degrees more reactive than 2, then 1, then methyl halide. But in SN2, methyl halide is more reactive than 1, then 2, then 3. So when we compare both these, we can find that the reactivity is just opposite of each. So what we can conclude from this, that the reactivity in the case of SN1, 3 degrees more reactive. But in the case of SN2, 1 degree, or we can say methyl halide, is more reactive. So this is all we have discussed in this video regarding the two type of mechanism, that is SN1 and SN2 mechanism. So the details of the other portion will be discussed in the next video. Thank you everyone.